So today, let's start our session on the disconnected team. So today we will do the selection of the isolator disconnector. So let's talk about this one. Meanwhile, I want to share you our SLD with you. Yes. So you can see that the line feeders here. So in our last class, we discussed on this conductor part. So I request you to do the same sizing, the conductors for all the places team. So I already mentioned I am using some ACCC single moves conductor here, and I am using twin bursts here because total 100 megawatt is pulling here. So in 33 kV to carry 100 megawatt, I have to lay the twin bursts. In substations, it is fine because we are having a plenty of gantry towers which can bear the weight of this conductor. In the transmission line, it is not possible. So this is the twin bus miss. And if you are not away, if you are not in some projects, you are not having the tower structures also to carry this ACCC twin bus miss. So in that time, you will go with a rigid bus like aluminum bus with a 4-inch or 3-inch, depends upon your current rating and other some factors. So that is a way of doing the selection of the conductor. So in our today's session, we talk about the isolator team, and tomorrow we will talk about the lightning arrestor. So for today, for time being, let's have the discussion, a selection of the isolator or disconnector, whatever it may be. So the IEC standard for is 60947, and the IS is 9921 team. Indian standard is 9921. So let's come to this one. So this is the disconnector team. So this is 60947 or 60129. A disconnector, what does it mean by a disconnector? Isolator. A disconnector or a disconnector switch or isolator switch is generally used to ensure that electric circuit is completely de-energized for service or maintenance. In a sense, suppose let's go back to our single line diagram. Here, what we are doing. So we are having these number of feeders. So now today I want to attend a maintenance work on this breaker. So if I want to attend a maintenance work on this breaker, so obviously I have to shut down only this part of the system from the rest of the system. So I have to open these both of the isolators to attend a maintenance work on this. So isolators are device which will operate only in no load condition, and it is ensuring the person to work and it is ensuring that the electric circuit is completely de-energized for service or for maintenance. It's a kind of a switch. These isolators will be operated only in no load condition. Again, I am stressing the point, the isolators or the equipment which will operate only in no load condition. Means when I want to operate the isolator, I have to open up this breaker, and also I have to open up the upstream breaker. So these two isolators will be opened up, and then again you can close and you can run the power. So I can attend the maintenance work on this. So you have to open up the breakers to open the isolator. You have to open the breakers first, then you are opening the isolator, and again you will close the breakers and you can run the system. So isolators always will be open in the no load condition. No load condition. Fine. So what isolator is? What actually isolator is? Isolator is nothing but a switch. So it will, when you are purchasing the isolator from the manufacturer, it will come as a setup with a isolator blades. These will called as isolator blades. You can see here, these are the blades. isolator blades, and complete base frame. This is the base frame, linkages, operating mechanism to operate, to close, open this. We required some electrical operation or mechanical operation to be there. So that operation, complete operation, will total this package is will call it as a isolator. If you want to purchase the insulator stacks also, you can directly purchase from the vendor. Or suppose if you are willing to purchase the insulator stacks as a lump sum quantity from a specific insulator manufacturer, so you can also purchase from him also. So it's a very good advice to take the insulators directly from the manufacturer. So you will not find difficulties when you are setting it up, because these insulators, the setting, the PCD, pitch circle diameter, where the 3 holes will be there. So it is to be exactly to be maintained. So it will be difficult for us to, if you purchase outside. So it's better to give directly for the isolator manufacturer only. So isolator, now we got a definition that a isolator is a device which will operate only in no load condition, and it ensure the person to attend the maintenance work safely, and also it ensuring that the electric circuit where the person is working, that is de-energized for work, to do for attending the work. Fine. So what are the parameters we need to specify or we need to consider when you are purchasing the isolator team? The first one is you have to know what type of isolator you are willing to purchase. What type of isolator in the sense? See, the opening wide, see, now you can, like this. Suppose this is my line, this is my line, and this is the switch. Suppose this is the one more line. Here I am placing the isolator. Now you can have an isolator like this, like one is a fixed, so it will acting a switch, close, open, close, open. So it is one side, it is fixed, other side, it is moving. If it is connected to this line, the power will flow. If it is away from the line, the power will out. So it is called as a single break switch, where I am opening only at single point. So it is called a single break switch, single break isolator. Single break isolator generally used for 11 kV and 33 kV systems team. Not 33 kV, mostly under the 33 kV system. Generally, single break isolators are widely used. And the next one is, if I am placing the switch like this, suppose this is the one, this is the switch, this is the support for this. So it is having 2 blades like this. So this is the closing position, and the opening position will be in this way. The black one is the open, this is the closed. Means the isolator is opening in this direction and it is closing in this direction. Opening, closing. This will open like this. This is moving towards this. This blade is moving towards this, and it will appear here open position. And I want to close, again reverse. So clockwise 90 degrees and anti-clockwise 90 degrees and clockwise 90 degrees. So whatever it may be. So if you are opening this side, so it would be clockwise, anti-clockwise. So whatever it may be. So clockwise, anti-clockwise, only 90 degrees shift it is there. So here the isolator is breaking at both ends, this end as well as this end. So this isolator will called as a double break isolator, double break disconnector. Double break disconnector means it's breaking at 2 points, and it is breaking at 2 points. So this isolator will called as a double break isolator. Double break isolator or double break central rotate isolator. because double break and it's centrally rotating. So double break central rotate isolator is also the same, or horizontal double break is also the same thing. Horizontal double break is also same philosophy. Same philosophy. So all these are same, different terminologies by different engineers. That's it. Double break isolator or DBCR, double break central rotate or horizontal double break, whatever it may be, the isolator type is the same. So it is opening at both ends. These isolators are widely used from 33 kV to 400 kV level. This is the widely used, and most of the projects you can see this isolator up to 220 kV. All the isolators are double break central rotate isolators from 33 kV onwards. In 400 kV, you can see this isolator sometimes, or else you can see one more isolator type, which is horizontal central break isolator. Means this is the 2 points of that. So it is having some connection like this. So this will be moved towards that. This will be more towards that. So these are the fixed for this one. So it's breaking at horizontal. So this is the horizontal central break isolators. The same thing if it is opening in a vertical way. So it is called the vertical central break isolator. It is in like this. So if you open, it just comes to this position. It comes to this position. These are different types of isolators. That's it, the only thing. So this horizontal central break or vertical central break isolators are used in more than 400 kV onwards. More than 400 kV and 400 kV onwards, they will use this horizontal central break or vertical central break isolators. And these isolators, these are the different types of isolators. So in all our course, at each and every segment, we are mostly we are talking only on this part of isolator team, which is because widely used one, double break central rotate isolator. So this is the one. So let's assume this is the R phase, this is the outgoing, this is the Y phase, outgoing, this is the B phase, outgoing. So this is the blade which will rotate in this direction. When you, after opening, all these blades will be in this way, in this direction. In this direction. So this is the representation. This is the different explanation of different types of isolators. Single break isolator, double break isolator, or horizontal central break or vertical central break isolators. We are mostly concentrating on double break isolator, what we are seeing further in our next slides. So let's come to the next. So apart from this, what are the other parameters we need to mostly concentrate on the isolator team? So to give a good glance, means to give a good glance for the manufacturer, so you have to specify these 6 parameters mainly, team. Apart from this, we are having.
Hi Santosh. Sorry to disturb. Can you? Actually, I'm unable to connect to this this class in last 10 minutes. So can you just go through the 5 slides back so that once I come through it?
No. The starting is this slide only. So these are the breaker. This will be next week, tomorrow, or maybe on next week class.
Okay.
This is the first.
Okay.
So what you are came, that is the same.
Okay, thank you.
Yeah. Wait a minute. Why my earphones are not working? Yes, 1.5 breaker also same, but again depends upon your project. Suppose if a 765 kV, you can see central break isolators, or you can use these isolators. In some projects, you can this is the isolators we are using. Fine. So let's come back to this one. So what are the main parameters we need to focus? We need to mention when you are choosing the isolator team. Means suppose now you are doing the project. So now we are at a stage that we completed the skeleton view of SLD, and we came to know that, oh, these are the equipments I required. So in our project, if you count, we are having nearly 13 into 2, mostly nearly 25 number of isolators, near to 25 number of isolators in our 33 kV site. So if you want, now you are asking the vendors, you are entering into the market and you are asking, I am having a requirement of 25 number of 33 kV isolators, and 1, 2, 3, 4, 5, 5 to the 10, 11, 12, 13, 14, 15. So 15, 16, 17. So 17 number of isolators or near to 15 number of isolators required for my 220 kV. If you just go through the SLD, you can see that number of isolators. So I required 25 number of 33 kV isolators and 15 number of 220 kV isolators. So now you are entering into the market and you are asking the prices from the different manufacturers like ABB, Siemens, Alstom, or other manufacturers, what well-known manufacturers. So these three now sending their technical details to us. So we are reviewing those technical details and we are checking whether all the technical particulars which are provided by the Siemens or ABB or the Alstom are complying to the standards of IEC or IS, or whether he is complying even with our specification. Obviously, our specification again we copied from the IEC and IEEE or AEC and IS only, Indian Standard or International Electrical Standards. So obviously it is from the same only. So just we are comparing that. Oh, this is my requirement. So we have to provide some technical specification on the isolator to the manufacturers. So then manufacturers will go through the technical specification and they will come to know that, oh, these are the main important conditions or the main things this Santosh want on the isolator. Obviously, the technical specification, what I prepared, that is drawn from the IEC and IS standard only. But because we have to give some kind of document to them to ensure this, so we are providing that. So that is a technical specification where we are giving a full deep description on the isolator, including what is the material, what is the current density. My isolator should be capable for electrodynamic withstand capabilities and also should be capable with thermal withstand capabilities. And we are talking about the tubes and the material for the tubes and coating and all the things, all the stuff, and type test, everything in a deep we are talking in the technical specification. So I will share you the technical specification to you team. So one of the example technical specification I will be shared by after this class. Again, I request you to please read once as a novel. Like no need to just read one time. Hold the document so you can understand some main points in that. So that is a brief description on the isolator. But today, when I am someone asked me that in a short. So when we are meeting these persons across the table, we cannot explain all the stuff of 50 pages content to them in 15 minutes. So we have to specify very important parameters, and these are the parameters will change from project to project. So those parameters we have to talk now. Rest of all the parameters, those are obviously same for all the manufacturers across the global, across all the varieties of isolator, irrespective of voltage level, irrespective of the current rating, irrespective of the type. The parameters what we are not talking here, those are mostly same, 99% or similar for all the isolators, because those are all we are talking there about the material of the isolator, and this is the size I required. So these are all again we already drawn from the our IEC standards only. So already the manufacturer has to comply with the IEC standards when he is attending to the type tester. So when he compiling with the IEC standards only, then he can pass some type test like temperature rise test, rated short circuit withstand test, and whatever the tests are there. So he will get the type test results, satisfactory type test results when he's complying to this. So obviously he will comply, he will agree for those things. So coming to this. So here we are talking about the main important things. Yes, creepage is come under the clearances. Clearances. Yeah. So the main one is, first one is the rated voltage. So rated voltage, you already know whether it's a 33 kV or 220 kV system. So for our case, let's assume we are having two voltage levels. So I am asking, I require a 33 kV isolator as well as a 220 kV isolator. So this is the voltage, rated voltage. Fine. Then what about the rated current? The rated current is, what is the current what is the isolator current required? Means what is the continuous current that the isolator can see all the time? Rated current. That is the rated current. So if you just recall our SLD, we are having 10 feeders. Each feeder is carrying 20 megawatt. As our project is 200 megawatt. So 20 megawatt in 33 kV level will gives you a current of nearly 370 amps, 360 amps. So this is the current rating I got. Suppose 360 amps is the current rating I received. So I am asking, I required 360 amps isolator for the line feeder. And if all the line feeders are connected and it's connecting to the transformer is 100 MVA. There I required nearly 100 MVA, right? So for 100 MVA in 33 kV, it's nearly to 1700 amps. So one more isolator I required is some 1700 amps. These are the two isolators I required here. Rated voltage is the maximum voltage. Highest system voltage is the maximum voltage. Rated voltage is your line to line voltage. Highest system voltage is your 36 kV and normal rated voltage is your 33 kV. Fine. So we are having 360 amps and 1700 amps. So 360 amps and 1700. There are two choices in here. And come to my 220 kV in 1000 for 100 MVA. What would be the current rating? Let's just be 400 amps in the 220 kV I required. And for the lines, I require suppose 600 amps. These are the some requirement in my 220 kV after calculating the current. These are the different ratings I got. Now, for my 12 number of feeders, for 10 number of that lines, I require 10 number of 360 amps isolators, and for two transformers, 2 numbers of these isolators. This is the way of calculating generally. Fine. Now, so you required 360 amps isolator, but the isolators are mainly designed. So in some project they will get 215 amps. In some projects they will get 390 amps. So it is not a measuring device as like a CT, right? It is only for isolation. So the manufacturers are across the global, as per the standards of IEEE, the isolator ratings available only for few current ratings. Here I mentioned those. This is the data retrieved from this IEC standard team. So these are the current ratings available in the market for the isolator, starting from 400, after 630 amps, 800 amps, 1250 amps, 600 amps, and so on to 6300 amps. So these are the ratings available in the market for the isolator. And if you ask me for 33 kV, the 33 kV, the minimum size of the isolator starts from 800 amps in the market, and it will be there up to 2000 amps. 220 kV, the isolators you can see 800 amps or 1250 amps or 2000 amps. So this is as per the market availability, you are taking that. So there is a no much wide range in wide, I mean the difference in the cost when you are going for high current rating stream. So 800 and 1250 amps not more giving you more this cost difference. No such a kind. So For here, in all my 33 kV, here I can select 1800 amps, and here I can select 2000 amps for my transformers. And similarly, in 220 kV, the standard ratings of that for the isolators are 2500 amps and 3150 amps and so on. So you can select 2500 amps for or 3150 amps for 220 kV. Even though if you ask 2000 amps, they will provide you 3150 amps isolators only, because they are already, all the manufacturers are type tested for those current standard ratings of this. So this is the rated current rating. Next, frequency, you already know 50 hertz is the frequency, or if you not for the other countries which offering for 60 hertz, then 60 hertz. And operating mechanism, what I will discuss about the different types of the things, single break or double break, what is that? And come to the fifth one, the rated short circuit current. Rated short circuit current is the so here again we are going to first class. In the first class, we discussed that my 33 kV system I am designing for all the equipment should be designed to carry 25 kiloamps per 1 second, and all my 220 kV equipment should be designed for 40 kV for 1 second. So that is the here. For the 25 kiloamps per 1 second for 33 kV and 40 kiloamps per 1 second for 220 kV. And come to the endurance class. Endurance class and isolators, these are not electrically operated. Obviously, these are operated in no load condition only. So here the mechanical endurance will come, means mechanical. How many times you are operating the isolator? We are having three types of mechanical class system: M1, M0, M suffix 0, M1 and M2. M suffix 0, you can on and off the isolators for 1000 times, and this is for 2000 times, and M2 is for 10,000 times. Means it's giving it some guarantee that my isolator, if you choose that isolator for M0, it would be less cost than this. So you are using only for general purpose. So you can on and off the isolators, open close, you can do 1000 times, open and close 1000 times. That is the mechanical endurance. And for that switches, you are having the electrical endurance, E0, E1, E2, because E0 is the for sample at switches, which will not make the current. But if you see in the GIS applications, you can see the at switches with the fast acting at switches, high speed fast acting at switches. So for those E1, E2, which is 2 times of the fault current or 5 times of the fault current or magnitude of the current. So those are the things will be there in the at switches. Where I will discuss that electrical endurances in our breaker class session table. So these are the main important factors we need to mention when you are choosing the isolator. So it says that suppose if a manufacturer came, so I'm saying that I require a 33 kV, 800 amps, 50 hertz, double break, central rotate isolator with 25 with rated short circuit current of 25 kV for 1 second, and endurance class is M0. This is the main thing. So by this you will get the total idea of this. So he will give a quote if he is having a if he if he's having the data, he can give the price across the table itself. So this is the way of, this is the general main parameters we need to specify when you are selecting the breaker. And apart from this, if you ask some important parameters that we will specify in the specification, that we have to we are including some clauses like my isolator should the electrodynamic withstand capability during my short circuit without any risk of repulsion of contacts. Means I'm telling that my isolator should ensure that electrodynamic withstand ability during short circuit without any risk of repulsion of contacts, and the current density factor, the current density at all the copper terminals, wherever you see the copper in the isolator, so those copper, the current density should not be less than 2 amps per square mm, should not be less than 2 amperes per square mm. And for all the aluminum contacts, it should not be less than 1 amp per square mm. And you have to, I am writing that my isolator should ensure the thermal withstand capability and wiping action during the closing or opening of the isolator, and all the tubes in the sense, this is the team. These are the tubes. See, these are the rods, and this is the one tube will run from here to here. So when I'm rotating here, this tube will mechanically coupled all this. So all this will be rotated by this blade will be rotated. So this tube should be, we will call this pipe as a tandem pipe. So the TANDEM, tandem pipe. So I am asking that my tandem pipe should be electro hard drawn electro copper material, electrolytic copper material, and we have to provide some silver plating of some 15 micron, something is there for 33 kV, and for depends upon the voltage level. We have to provide we have to mention what is the silver plating to be provided on those things. And also like for some special purposes, if you want to give the isolators, if you're using the isolators for double bus bar configuration where your isolators are opening in the load condition, in those conditions the isolators are specially designed. So we have to provide some other parameters as per IEC. In that one of the ways, my isolator should be suitable for isolate the low capacitive or inductive currents like 0.75 amps at 0.15 power factor. So these are the things we need to specify, general parameters as per the IEC. These are all the things we can see in the IEC document. So all these things again we are specifying mainly in the specification, and these are the parameters we are directly providing in this as a summary in the specification, as well as directly in the bill of quantity, where you are raising the request of purchasing this isolator. In a short note, we are mentioning all these things in a brief. So when you are preparing, when you are doing all these things, so you submitted to the client, so manufacturer. So you sent to 3 manufacturers, X, Y, Z. So now X, Y, Z again revert to you based on your request with some documents. Like one is the GTP, guaranteed technical particulars, where you can see all the isolator ratings, everything. So again, you have to compare those with respect to our standard, our technical specification, whether these ratings are matching with our specification or not. If any difference, again, we are putting a point to that person. So that is one more document. One document we will get. And apart from this, the GA drawing means general arrangement drawing of the isolator. To know this is the GA drawing. To know what is the clearances maintained. Again, the clearances again, we have some we have to maintain the face-to-face clearances, face-to-earth clearances at every voltage level. Respect to the voltage level, the clearances will change. For 33 kV, it is like minimum is 450 mm, and in 220 kV with a BIL level of 1050, we can see 2 meters. So it will be changed for 1 to 1. So we have to consider all these things. To just review whether he is satisfying the clearances or not. So we require the general arrangement drawing, and this general arrangement drawing should be provided by the manufacturer, because this is again will be useful for our earthing connectivity, for earthing connections, and for the civil foundations. For all this, we can easily get to know how this, and for also to establish how to string these isolators in the substation. For development of the sectional views, layouts, we required this general arrangement drawing. So he will provide the general arrangement drawing, and this is the front view of the view. So this is the picture of this. So this is the view of this, and this is if you are seeing the person from this side, this is the view. This is only for one phase, R phase, first limb, second limb, and third limb. R phase, Y phase, B phase. Either first limbs or third limbs. Central you can't say, you can know. And also he will provide some other drawings like marshalling box drawing. So marshalling box drawing is this is the marshalling box stream. So from where you can operate this isolator, you can open or close isolator mechanically or electrically. So how we will see now. So those drawings will also